So we're going to start looking at transformations of these functions. And the first transformation we're going to do is a vertical stretch. Remember, a vertical stretch is when you multiply your entire function by a number. So these are all vertical stretches. You're multiplying by vertical stretches or compressions. I stopped when I got to this one because that's actually a compression. It's less than 1. So when you multiply your function by a number, you multiply the entire function by a number, that's a vertical stretch. For sine and cosine, that's actually going to affect the amplitude. So this red graph, f of x, has a vertical stretch of 3. And if I look at the red graph, the midline is at the y-axis. So the distance from the maximum to the midline is 3. So the amplitude is actually equal to the vertical stretch. And the reason it's equal is because an unstretched graph, a regular sine graph, has an amplitude of 1. If I multiply by 3, that's going to stretch everything 3 units, 3 times 1. So if I look at the G graph has an amplitude of 1/2. And so let's look at the G graph. Oh, yep, it's going up and down to 1/2. Okay. And it doesn't matter that we have sine or cosine, it's the same because the amplitude of sine and cosine are normally 1. So a multiplier of 1/2 is going to be a compression of 1/2 for both of those two functions. If I look at the h function, the amplitude would be 4, and there it is. There's the amplitude of 4 that you can see on that graph. And then for the j function, the amplitude would be 1/2. It's a vertical stretch of 1/2. 1.5. I don't know why I said 1/2. So here's the stretch of 1.5. There's our amplitude. All of these have the same period. They still have a period of 2 pi. It still takes 2 pi to complete a revolution. And that's the way we change the period is we do a horizontal stretch or compression. So for j, we have a multiplier of 2 here. So that for j is going to be a horizontal compression. Okay, that's going to smoosh the graph sideways. So now our period is going to be shorter. We multiplied by 2. Instead of having a period of 2 pi, we're going to notice we start here at 0. Our y-intercept is 1. The next time we reach 1 is at pi. So our period got cut in half. We had a multiplier of 2. Our period got cut in half. That's a horizontal compression. The other one, if we multiply by 1/2, that multiplier of 1/2, that's a horizontal stretch. So our period gets longer. In order to complete a sine function, we would start at the origin, go up to 2 pi. Oh, we're not done yet. We would need to complete the cycle. So let's actually start here at negative 2 pi. So negative 2 pi to 2 pi is one full cycle of this graph. And so it's going to have a period of 4 pi. It's going to be a stretch of 2. Find amplitude and period if we don't have a graph in front of us is the amplitude is the vertical stretch. So the amplitude is going to be the absolute value of that a. The reason it's absolute value is because if you have a negative a, that would just be a reflection across the x-axis. So that doesn't affect the amplitude. The period is going to be 2 pi divided by the absolute value of b. Again, the reason why it's absolute value is because if it's negative, that would just be a reflection across the y-axis. That's not going to affect the period. And again, the reason we're dividing is because horizontal stretches and compressions are horrible. So that's going to affect our period. If b is larger, the period is going to be smaller. If b is smaller, the period is going to be bigger. We're going faster if the b is bigger. All right, so in this example, I have a graph, but I'm going to just try to do it by looking at the equation. So even though I have a graph, I'm going to look at the equation. So here's my equation, y equals 3 times cosine x. I'm going to try to look away from that. If I have that equation, then a is 3 and b is 1. So the amplitude is going to be just a, or absolute value of a, which is 3. And the period is going to be 2 pi divided by 1, which is 2 pi. And so if we look at our graph now that we've figured it out, our amplitude is 3 units. So from the midline up to the maximum, from the midline up to the maximum is 3 units. From the midline down to the minimum is 3 units. The period is how long it takes to complete a cycle. We start at 1. The next time we're at 1 is 2 pi units. So that's 1 cycle. And again, it doesn't matter if you have sine or cosine, it's still going to be, the original period is still 2 pi, so the stretch and compression is going to affect that same period. This one is a sine function. For this sine function, a is -1, which means that the amplitude is going to be 1, because that's the absolute value of -1, and b is 2, which means the period is going to be 2 pi divided by 2. Multiplying by 2 speeds up our interval, so our period is shorter. So our period is going to be pi. Now let's look at our graph and see if we're correct. From the midline to the minimum, I see that that's 1 unit. From the midline to the maximum is also 1 unit. And then the amount of time it takes to complete a cycle, well, we start at 0, we go down to -1, we go back to 0, we go up to 1, and then back to 0. It takes pi units to complete 1 cycle. All right, I'm going to have you try this. Unpause the video after you have attempted these graphs. So you need to find the amplitude and the period. All right, so for the first one, A is 1/3 and B is 1/2. So the amplitude is going to be just 1/3. The period is going to be pi over 2 pi divided by 1/2. If I divide by a fraction, that's 2 pi times the reciprocal. The reciprocal of 1/2 is 2, so the period is going to be 4 pi. This multiplier slows down our function. Our function is slower. It takes longer to complete a period. It's a stretch vertically. And then for B, the amplitude is going to be 2 because that's A. And B for this one is pi. So the period is going to be 2 pi divided by pi. So our period would be 2. And if I look at a graph of those functions, I didn't mean to write on top of where my graph was going to show up, so I'll get rid of that. If I look at those two functions, I should be able to tell by looking at them which is which. Here's the cosine function. It doesn't matter whether it's sine or cosine, but the cosine function starts at 1. And so if I look for a complete cycle, it looks like the complete cycle is from -2 to 2, -2 pi to 2 pi. So the height is 1/3 because we're not all the way up to 1, we're multiplying by 1/3, and the period is 4 pi. And then for this sine function, the amplitude is 2, there it is, and our period is going to be from 0 to, I think that's about 2 because it's not quite to pi, it's a little past pi over 2. Anyway, that is how you find amplitude and period. That is all I'm going to cover today, and good luck with your homework.